Sit here, I'll sit here.
Hey guys, welcome back to my channel. If you guys don't know, I'm Bianca. So today is the day after Christmas, and I just want to show you one thing I got. Like one of the things I got. I got this big book, chemistry textbook, and at first I was really mad that I got it. But then I was looking through, and then I came across chapter 11, properties of gas. And that got me thinking about all the relatives in my family and how they work with gases. So for today's video, I'm going to be talking about different gases in transportation, propulsion, but I'm not going to do that alone because I have my whole family tree here to help me. So I'm going to introduce you to them right now. Hey guys, it's Burly Bianca. So I'm Bianca's cousin, and she told me that you guys wanted to know more about what I do revolving around gases. So as you can tell, I'm not in Canada, I'm in New Zealand. I've been flying hot air balloons for about 13 years now, so I would say I'm pretty familiar with the gases involved in the hot air balloons. So to summarize, hot air rises in cooler air because hot air has a smaller mass, so that means it's less dense, so that means it can rise faster than cooler air. So in a hot air balloon, there's a burner at the top above your head. Not above your head, but like right in the center. And then it basically mixes air with propane to create a flame. Propane, C3H8. So then it warms up or heats up the surrounding air, and then in the balloon itself it comes as a big envelope, and basically all the hot air gets trapped inside of the envelope, which causes the balloon to rise. So at the top of the balloon envelope there is a parachute valve, which is like a flap that releases the hot air at a constant rate, so it decreases just so all of the hot air isn't released. The best thing about hot air balloons is that it uses propane, so it's a mixture of natural gas and crude oil. And propane is considered a clean alternative fuel by the 1990 Clean Air Act. Propane is naturally odorless and colorless, but the chemists add artificial scent to it just for safety purposes when handling with propane. So there's nothing much left to say other than the fact that hot air balloons uses a burner to mix air with propane to create a flame. But that's pretty much it. Hot air balloons are pretty simple because it doesn't take up much gas or need a lot of technology to start it up. But I hope to see one of you guys ride a hot air balloon in the future. Okay, bye! Hey guys, I forgot to mention earlier, I just transferred to the new location for my hot air balloons. But in 1937, there was the Hindenburg explosion. Now, necessarily it wasn't hot air balloons, but it was an airship. And they did use hydrogen gas. That's why we don't use helium or hydrogen gas to lift our balloons up, because it's more explosive and flammable. That's why it's better for us to use propane and crude oil to burn and create a flame. Oh, didn't see you there. Hi, I'm Bianca. I'm Bianca's uncle. And today I'll be showing you guys the gases in the tires. If you want to learn more about the gases in your tires, follow me. Put your seatbelt on. Safety is always important. Did you know that the air we breathe in is the same air we put in our tires? So that means there's 78% nitrogen, 21% oxygen, and 1% of miscellaneous gas. Nowadays, automotive companies suggest that we put pure nitrogen in our tires. Now let me tell you why. Nitrogen is an arid gas. That means it can't react with other chemicals. This prevents corrosive and explosions from happening. But But the main reason for using pure nitrogen is the resistance to leakage. Nitrogen molecules find it harder to sneak out through the tire past the rubber molecules than oxygen molecules. This makes nitrogen a good bet for race cars, aircrafts, heavy-duty equipment where precise or constant pressure is needed. Follow me. Bianca Calcium's back! You're probably wondering why you should have nitrogen tires rather than air tires. Well, I'm gonna go tell you why. Right now. It improves steering. It improves handling. It improves braking. Reduces oxidation. Eliminates interior wheel corrosion. Decreases false alarms from the tire pressuring monitoring systems. Other than the fact that nitrogen tires are really expensive, nitrogen spreads throughout the walls of the tires 4 times slower than regular air. Filling up your tires with air is more convenient because you could fill them up at your regular gas station. For nitrogen, you have to go to your automotive dealer shop. You could go to Bianca Calcium's auto shop to get it refilled, but that costs money. Some people may think that having nitrogen in your tires will increase the fuel economy, but that's not the case because having nitrogen or having air in your tires doesn't affect the function of the actual vehicle. So whether you want air or nitrogen in your tires, hit up Bianca Calcium's auto shop today. Hey guys, I'm Bianca. I'm Bianca's boyfriend. I've been working with NASA for the past 18 years. I've been an astronaut for 13 years. I'm in the washroom right now because my office is unavailable. But today I'll be talking about the gases involved in rocket propulsion. So I just came back from the moon, so I'm still trying to get used to this teaching thing. So let's get started. A rocket engine is a device that produces a force by pushing gases at high speed out of a nozzle. Rocket engines mix chemicals such as petroleum and liquid oxygen at a very high pressure and temperature. They are burned in a combustion chamber to turn the chemical energy into motion. To accelerate the flow and produce thrust, hot exhaust that had been produced by the combustion chamber is passed through a nozzle. This produced exhaust is the accelerated gas and working fluid in a rocket. There are 2 types of rockets, a liquid rocket and a solid rocket. In a liquid rocket, the propellants, the fuel, and the oxidizer are stored individually. They are pumped into the combustion chamber. In a solid rocket, the propellants are mixed together and packed into a solid cylinder. The propellants don't burn unless they are exposed to a source of heat that is provided by an igniter. Once it starts burning, it proceeds until all the propellants are exhausted. You can stop thrust in a liquid rocket by turning off the flow of propellants, but with a solid rocket, you have to destroy the casing to stop the engine. Liquid rockets are heavier because of the individual casing and storage tanks. Liquid rockets are heavier because of the individual casings and storage. The propellants are loaded before the launch. A solid rocket is much easier to handle and can sit for years before launching. Rocket propulsion can be explained using Newton's third law. Every action produces an equal and opposite reaction. When a rocket shoots fuel at one end, this propels the rocket to move forward. Hi, I'm Bianca, and I am Bianca's aunt. I'm currently in Vancouver right now because I work for the government of British Columbia. In the topic of improving air quality, we are trying to set new standards for new lightweight vehicles. These will reduce carbon dioxide emissions by 30%. It will also reduce our pollutants from fossil fuel combustions. Another initiative we're trying to do is clean up emissions from public transit and school buses. Lastly, we will support greener ports and marine vessels through the Green Ports and Marine Vessels Emissions Reduction Project. It's me again! So you've met half my family, so I hope you enjoyed that. Oh, and I also hope you guys noticed that they're not teachers, so they're pretty bad at teaching, but it's okay because my uncle, who's a teacher, he wasn't available. He's in Russia right now, so that's why, and I couldn't get a hold of him. But yeah, I hope you guys enjoyed my video. Hope you guys gained some knowledge, and like and subscribe, and I'll see you guys in my next video. Bye. Calcium's automotive shop right now. Look, I'm going through Saturn's rings. Whoa. Whoa, I'm in space while I'm floating. I tripped. Oh. Whoa. I look like a Martian instead of an astronaut. It's okay. It's okay. Do you see that? That's a star. Yeah, that's a star. And then over there, that's the sun. No, that's not the sun. I said that was the moon. We're coming home now. I'm coming home. It's been 99 light years, but I'm coming home. That costed money. That costed $1 billion. I'm back. Now I'm gonna be telling you more important and advantages of nitrogen tires. Bianca Calcium's back. So I'm